Finding initial temp equals equation Q equals M times C times triangle T equals M times C times T final minus T initial. So the T initial equals T final minus Q over M times C. First we'll solve for M, which is the mass, so we take the liters times 1000 milliliters over 1 liter times 1.11 grams over 1 milliliter equals ans in G. Now we solve for Q, which is in joules. So we take kJ times 1000 J over 1 kJ equals ans in J. Na below 0 will be mixture releasing heating, and above is absorbing. Now we can solve for T initial, so we take the temp of the mixture in Celsius minus our ans in joules over our ans in G times 3.140 J over G times C. Simplify and you get ans. 2. To find energy of compound, you make a complete and balance equation from the two compound element given in the problem and triangle RH, which will be given. Now we take grams of the first element compound and times it by 1 mole of that element compound over molar mass in G of that element compound times the amount in triangle RH in kJ over amount in the element compound equals ans in kJ. Do this for the second compound with that element mole over molar mass times triangle RH amount over 1 mole of second compound. The ans is smallest amount for the limiting reagent will be produced. 3. Calculate total heat energy transfer in kJ equals, so depending what state the G of the equation starts as our A and each be B2E while it turn to its final state. If it is going up the states from ice to steam, we will add and opposite if we go from steam to ice. We be using this equation Q total equals Q to B plus QB to C plus QC to D plus QD to E. It be minutes all that going down the opposite way. But that equation equals M time triangle H FUS plus M times C times triangle T plus M times triangle H FAB plus M times C times triangle T. So we have Q total equals parenthesis gram in problem times the amount in triangle H FUS J over G times 1 kJ over 1000 J parentheses plus parenthesis G times C compound in LJ over G times C times parenthesis compound BP minus M dot P of compound C parenthesis times 1 kJ over 1000 J parenthesis plus G times triangle H FAB kJ over G parenthesis plus parenthesis G times C compound in GJ over G times C times parenthesis the final C in question minus BP of compound C parenthesis times 1 kJ over 1000 J. Q total equals kJ. 4. Specific heat capacity of solid metal uses formula Q metal plus Q water plus Q cal equals 0, so parenthesis M metal times C metal times triangle T metal parentheses plus parenthesis M water plus C water times triangle T water parentheses plus parenthesis M cal times C cal times triangle T cal parenthesis equals 0. C metal equals minus bracket M water times C water times triangle water parenthesis plus M cal times C cal times triangle T cal parenthesis bracket over M metal times triangle T metal. Plug in the mass of water in M water, plug in heat capacity of water in C water. T water is the temperature of water change minus each other. The same will go for the cal, you plug the mass and heat capacity and temp change in those places. Also the same for M metal and T metal, and the ans equals J over G times C. Temp change is big temp minus is small temp. 5. Calculate triangle U, so we use this formula QR plus Q water plus Q bomb equals 0, so QR equals negative parenthesis plus Q water plus Q bomb parenthesis. QR equals negative bracket parenthesis G water times heat capacity of water times parenthesis reaction of temp water minus initial temp bracket plus bracket heat capacity of bomb times reaction temp of water minus initial temp bracket equals ans in J and times it by 1 kJ over 1000 J equals ans in kJ and divided by G sample times molar mass of sample over 1 mole of element equals ans kJ over mole. 6. Determine enthalpy reaction uses QR plus Q solution equals 0, so M solution equals add G plus G of single element equals ans G. So Q sol equals M solution ans times specific heat solution times change in temp, so big minus small equals ans J. So QR equals negative Q solution ans and triangle RH equals Q solution ans over G of single element times 1 kJ over 1000 J times molar mass of single element over 1 mole of single element equals ans kJ over mole. 7. Calculate triangle RH, so we be given triangle FH of the reaction compound element in reaction formula and triangle FH first compound element. So triangle RH equals sideways M inside N triangle FH parenthesis product parenthesis minus sideways M inside N triangle FH parenthesis reactants parenthesis equals bracket parenthesis amount of moles in. Reactant compound over 1 mole Rxn times given triangle FH amount in for reactant minus parenthesis bracket parenthesis amount in first compound mole over 1 mole Rxn times triangle FH. For first product Kj over mole NH3 parenthesis plus 1 mole of second element over 1 mole NH3 parenthesis plus parenthesis 1 mole second compound over 1 mole Rxn times amount in triangle FH but could not be given, so it be 0 equals N's Kj over mole. 8. Molar enthalpy. For this you'll be given reactant and make the product and balance it like O always has 2 and branch has 2 element with 2 of it in it. H, N, F, O, I, Cl, branch. 9. Determine triangle RH, so there be a given formula we be given 3 reaction that have either the compound in the formula given or just the element with their own triangle RH numbering Rxn1 down to Rxn3. Our goal is to have the similar compound or element be on the same side and amount as in the formula given. So if you need to get the compound or element on the other side, you need to make the triangle RH the opposite charge. If it's plus, put it minus. If you need to time the compound to get the same amount in the formula, then everything in that reaction be timed by that amount, even the triangle RH. You'll cancel out anything that isn't in the formula and combine same elements if it is in the reaction. Add all the RH to get RH for the problem formula.